So we're moving back to section 2.7. I didn't want to teach you this while we were doing all the other work, but now we're ready to do 2.7. I like to keep conversions of moles and stoichiometry together, and now we're moving toward more descriptive chemistry. So there's an important note here. You will see on the very last page, there's this picture right here of a periodic table showing you the charges of elements in a specific column of the periodic table. And in the first paragraph, we'll be referring to this pretty often throughout today's video. And the descriptions are all in here of what you saw in that periodic table at the end. All right, so naming compounds. We're going to go over determining the name of a compound from its formula, and we'll also go over learning a formula from its name. We're going to start with ionic compounds. There are two types, type 1 and type 2. Type 1, you automatically know the charge, and you will want to copy this down. So all alkali metals, we know the charge is +1. It's because of this right here. We know the charges of all these. And we also know silver, zinc, and aluminum. You'll notice these go 1, 2, 3. So that's how students often memorize these, is this little diagonal. You might want to write that in your periodic table. Draw a diagonal here. Silver's always +1, zinc always +2, aluminum always +3. So these three metals and the first two columns are the ones you will be responsible for. There are some other metals that have a known charge. They have only one possible ionic charge, but we will not worry about those in this class. Okay, I've listed cadmium. I never give you problems with cadmium, so you don't have to memorize that cadmium is +2, but you do have to memorize these other ones. Okay, for naming these, straightforward. You write the name of the metal and the name of the nonmetal. You have to change the ending of the name of the nonmetal to IDE. Some background information here. Now, type 2 compounds, we don't know the charge because there's more than one possible charge. If you're not type 1, you are type 2. You're going to have to do something to calculate the charge. You calculate the charge, and then you write the name of the charge in Roman numerals, in parentheses, after the name of the metal. And then you just write either the nonmetal or the polyatomic ion. Now, in all of these names, the second element, if it's just two elements, the second element will always have its ending IDE, unless we have an acid. There's all these exceptions in chem. Nothing is straightforward. Let's do some examples. So Na, we look at our periodic table, and we see Na. We know the charge automatically. We just write the name. If you know the charge, you don't have to do anything special. These are really easy. And if you can figure out what it is, go ahead and write it. Otherwise, here you go. Just sodium, no Roman numerals, and chlorine becomes chloride. Next one, Ca, calcium. We look at the table. Calcium's right here. It's in a known charge column. So alkali, alkaline earth metals. We don't worry about putting Roman numerals into the names because we automatically know their charges. So go ahead, pause, fill this in. There's your answer. Okay, this one. Okay, notice you have three elements. In this case, we're going to have to look up this polyatomic ion. Whenever you have three elements, you're going to use that polyatomic ion sheet that I gave you in class. You will look up NO3, and you will find that the name of that is nitrate. Aluminum, we're going to look up on the periodic table. That was one of those. It's not an alkali or alkaline earth metal, but we do automatically know the charge, so we do not write a Roman numeral. Let's go back here. Where were we? There we go. We just write aluminum because we automatically know the charge. And we write nitrate. We don't change the ending to "ide" when we have polyatomic ions. It's just aluminum nitrate. Those were easy. Now comes the hard part. When you don't know the charge, this is a little more complicated. So you look on your periodic table for copper. Copper is in the middle right here. This periodic table has been cut off a bit. We don't know the charge, so we're going to have to calculate it and put the charge as a Roman numeral after the name copper. So chlorine. We look up chlorine. We look it up in the periodic table, and we see chlorine is in the -1 column. So we know chlorine has a charge of -1, and we have two chlorines right here. So each chlorine is -1. The total here would be -1 times 2, or -2. Remember the whole thing, each chlorine has a charge of -1. And there are 2 chlorides because of that 2 down there. So the total negative charge is, I just told you already, -2. We need to have this balance out to 0. So what does the copper have to be? We only have one of them. What does the copper have to be? It must be, you can always pause or just fill it in while I'm talking. It has to be +2. So the name now is copper, and then we put the Roman numeral 2 in for the copper, and we write the name of the second element. So you can pause, write it in, or look at the answer. Copper 2 chloride. Not so bad. Getting a little more complicated. We've got nickel. If you look up nickel, you'll see it's in the middle of the periodic table. It's in this first row. It's missing from this one. And we don't automatically know the charge, which means nickel is a type 2 metal. So we're going to have to figure it out. So we look up oxygen. We look up oxygen on the periodic table. And here's oxygen. It's in the, what's the charge of that oxygen? -2. And how many oxides are there? Right there. There are 3. And what's the total on the negative side? We have -2 times 3, which is -6. We got to make this total add up to 0. So if the negative side adds up to -6, the positive side must add up to +6. There are 2 nickels that total +6. So now think, if 2 of them equal +6, then one of them must equal, whoops, +3. It's just the total divided by the number of atoms to get the charge on the nickel. Now we're going to have to write that number as a Roman numeral. So it would be nickel 2, nickel 3. Did I say the charge was +2? I know it's written right here. I'm not sure what came out of my mouth. We have 2 nickels, total of 6 on the charge, so each nickel is +3. We have nickel 3 oxide. Okay, here, notice we have a polyatomic ion. And on your sheet, that probably is not lowercase, subscript. But you should recognize there's this PO4. We're going to have to look that up on the polyatomic ion sheet. If you want to take a moment and look that up, you should. Okay, cobalt happens to also be in the middle of the periodic table. It's in this first row, but it's not showing here. You should have your periodic table out whenever we're doing these videos. Okay, so the cobalt, oh wait, we know the phosphate. You looked this up, right? On your polyatomic ion sheet, you found it was phosphate, and you should look up that charge. It is -3. How many phosphates do we have right there? We have 2. So what's the total negative charge? If I have 2 -3s, that total is -6. Now, we need this total to add up to 0. Well, we have -6 on the negative side, so we need to have +6 on the positive side. All right. We have 3 cobalts, and they have to add up to 6. So 3 times what is 6? Geez, I keep doing that. 2. Each cobalt has to be 2. So the name of this would be cobalt 2-phosphate. We don't change the ending of polyatomic ions to IDE. We keep them the same. All right, molecular compounds. So these are super easy. All these little prefixes here, if you see hepta, it means 7. If you see a 7, you write hepta. These go in front of the element name. So and again, the second element, we change the ending to IDE. There are some weird little things that happen. If we have only one of the first atom, we don't have to write mono for 1. We just omit it. So whenever there's only 1, for the first atom only, we leave off mono. And for oxygen, because some of these end in A, if you said tetraoxide, it might sound funny. So I accept if you put the A in. but some books have this as tetroxide or pentoxide or hexoxide or heptoxide or octoxide. I would say octaoxide or decaoxide. So the dropping the A or the O is not a hard and fast rule. Okay, so look up the 2 for the nitrogen, and that is di. You look up the 5 for the oxygen, and that's penta. You probably have done this already. It's very straightforward. And the prefix means in front of, before. So it's di to dinitrogen pentaoxide. Try these other 2 on your own, and I'm just going to show you the answers. So pause this, and then check your answers. You should have paused by now. Okay, quick note on the carbon dioxide if you got it wrong. There's only 1 carbon. We leave off the mono, so we don't say monocarbon dioxide. And on the oxide, I left the A in. If you wrote decoxide, I wouldn't mark it wrong. All right, so that was ionics, molecular, now acids. You're learning a lot today. Okay, acids, there's 2 types, binary, ternary. We're always going to work with, there's an H in front. So acids contain H. And binary acids, the name, first off, binary would mean there's 2 elements. So if there's only 2 elements, you write hydro-blank-ic acid. Blank is the root of the name of the non-hydrogen element. Ternary, 3 elements. We write the name as blank-ic. Notice there's no hydro in these, no hydro. The way that you know you have a ternary is the word hydro is missing. This word acid, that's what denotes that we have hydrogen in the compound. Okay. So another key thing, 8 becomes ic, 8 becomes us. So let's do some examples. Doesn't make too much sense till you start doing it. HBr, clearly a binary, 2 elements. So bromine, what's the root? Brome. So we just stick that here, hydrobromic acid. Easy. So binary, so we would keep hydro. And the root of the chlorine is chlor. So the name is hydrochloric acid. And you can always pause, try to do these on your own. I'm just going to uncover this. You should pause because I'm uncovering it right away. It should be straightforward. Now the ternaries get a little tricky. So notice there's 3 elements. Ternary, that means we've got a polyatomic ion right here. So you look up NO3, get out your polyatomic ion sheet and look up NO3. Nitrate. We change the 8 to ic. Remember, 8 goes to ic, 8 goes to us. So we, instead of nitrate, we say nitric acid. There you go, right there. Notice there's no hydro. This word acid right here says there's hydrogen in the compound. Okay, H3PO4, again, polyatomic ion, because there's 3 elements. You look up PO3, you find out that's, what is it? Phosphate. What does ite become? Ite goes to us. So, now the name is a little strange on this one. It becomes you might think it was phosphorus acid, but with phosphorus we have a little bit of a difference in here. We put the OR in, but phosphorus acid. Okay, sulfur, same thing's going to happen. But first, identify the polyatomic ion. It's sulfate. And 8 becomes ic. So the name you might think is sulfic acid, but sulfur and phosphorus, when they're in acids, are written a little bit differently. Sulfuric acid. We add the UR to polyatomic ions that have sulfur in them. All right, now this ic, ate, itis, we have a little phrase to help remember it. Ic, I ate it, and I got an itis. That is how to memorize this, and that's how different classes have used this in the past. So it goes to ate goes to us. And itis is like a disease. So you ate something icky and you got a disease. Okay, now we're going to go backwards. So we just learned how to go all these formulas to names. Now we're going to do the opposite, the reverse. But you've seen this all, so it should be straightforward. We'll do a whole bunch of examples. Okay. Ionic compounds, we need to make the charge add up to 0. You know you have an ionic compound if you have a metal and a nonmetal. So Na, you look it up, first column, we know the charge is 1. Chloride is in the, which column? -1, -2, -1. So to balance this out to 0, we need 1 of each, and the formula would be just NaCl. All right, calcium bromide. Calcium, we know the charge, it's in the second column, that means the charge is 2. Bromide, we look up bromide, and notice bromide's in the -1 column. You should know how to do these columns now. So where did we go? Bromide is in the -1 column. How many bromides do we need for 1 calcium? We got to make this add up to 0. So we need 2 -1s to make the total add up to 0. So the formula is CaBr2. Okay, aluminum nitrate. Aluminum, you know, is +3. Nitrate, you look it up on the polyatomic ion sheet. It is NO3 charge of 1-. So, how many of each do we need? We need 3 nitrates to balance out the 1 aluminum, and the formula becomes AlNO33. Okay, these ones, same exact idea, but you're told the charge. So the Roman numeral tells you the charge, this copper is 3. Okay, you should pause or just try to do these all on your own. You look up chloride, it's in the -1 column. How many chlorides do we need? For 1 copper 2, we need 2, and the formula is CuCl2. Okay, I'm just going to uncover all these things now because it should be straightforward. You should pause this, do these on your own to check for understanding. And there you have it. Okay. So you should have checked yours. Okay, molecular, super easy. The prefix tells you how many. So di means 2. You look in that chart that we had right here. Di is 2. Tetra is 4. Was there a 4 there? No, penta. Penta is 5. So we have N2O5. Carbon dioxide, 1 carbon, because there's nothing there. Di is 2, so it's CO2. Tetra, look it up. Deca, look it up. P4O10. Okay, and finally, the acids. So, you have to make the total charge add to 0. Acids confuse students because of this hydro, like, do I include the hydro, do I not? When do I have hydro? First off, acid means H. Hydro means binary. So if you see hydro, you know you're not dealing with a polyatomic ion. So, hydro is present. So we have hydrogen, and what's that second element? It is bromine. And hydrogen has a charge of 1. Bromine, look it up in its column. Its charge is -1. So how many do we need? We need 1 of each, and the formula would be HBr. Okay, I just noticed okay, if hydro is missing, you are looking for a polyatomic ion. Oh, this is a reminder. I'm having you write this often. Write this down in your notes. It goes to 8, S goes to 8. For polyatomic ions. I want you to memorize that. Can you tell I keep having you write it over and over? Okay, hydrochloric acid says we have binary because hydro's in the name. What's the second element? Chlorine, which is, hydrogen's always in the +1 column. Chlorine is in the -1, so we need just 1 of each to make it add to 0, so HCl. Hydroiodic, hydrogen and iodine. Hydrogen +1, iodine, look it up, -1. We need 1 of each, and the formula is just Hi, very simple. Oh, now we've got some polyatomic ions. So nitric. Acid says we have hydrogen, but what's missing? Hydro. There's no hydro, so you're looking for a polyatomic ion. This is not binary. So recall, what does ic become? It goes to 8. So we are looking for nitrate. Look up nitrate, and the charge on nitrate is, got your polyatomic ion sheet out? It's -1. Well, if we have H is +1, nitrate is -1, we need 1 of each, and the formula is just HNO3. Hydro's missing. Acid tells you you have hydrogen. Hydro is missing. So you're looking for a polyatomic ion. Look it up. Now, this time we have us. What does us become? Ite. So we are looking for phosphite. And the charge on phosphite is, you should have looked this up by now, -3. We need to make this add to 0. +1 and -3. How many H's? We need 3 H's for 1 phosphite. And the formula becomes H3PO3. Last thing, sulfuric acid. So acid says we have hydrogen. Hydro is missing, so you're looking for polyatomic ion. We've got an ic. It goes to 8. So we are looking for sulfate. Look it up. And the charge on the sulfate that you should have looked up is -2. So how many H's do we need to balance out this -2? We need 2 of them for 1 SO4 2-. And the formula becomes H2SO4. And there you have it.